There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells will electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine, film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where
100 grams of this cabbage. Not 60. Tap. No. Oh, almost there. Okay, that's fine. Alright, so now we have 100 grams of cabbage that we have in this 400 mils of water. So we're just waiting for 10 minutes for this to boil. Kind of get that cabbage in there. Alright.
Guys, it's just 100 milliliters. 50. Huh? 50?
50.
All right. There you go.
Okay. Now we have our cabbage boiling, so lower the temperature a little bit. So this doesn't spill over. There we go. Now we're gonna do this let this boil at this point for about 10 minutes. Then we're gonna add the water to this beaker.
All right.
Then we are going to add the sodium alginate.
With 50 ml of water.
It's going to become a little clumpy, so all you have to do is continuously stir it until everything disappears.
Sure.
Yeah, it is very clumpy, so
It
eventually
will-
we'll have to heat this up.
We will need to heat it up just a little bit so that it all becomes clear. We have to label all of our beakers so that we know what we are using. So we put, after you finish making everything, we need to label so that we know exactly what we have. So for the sodium alginate, which we put on the hot plate to heat for a little bit, our thing is going to say sodium alginate, it's 2% sodium alginate with our names on it, and then also the date that it was made. I'm going to put that on there and label that.
Thank you.
Now we are going to make a 100 milliliter solution of 1% calcium chloride. So we're going to take a gram of this and 100 milliliters of water. Awesome. And we're just also going to dissolve that in the water.
Be sure to have a few stirring rods because we're going to need several.
We're also going to make a label for that, which is 1%. Oh, I lied.
This This is a lot easier to dissolve than the sodium alginate. You can tell it's already pretty much in solution at this point. I have a few of them. The bottom, still dissolving, but definitely a lot easier.
Level.
Right. So now we are coming down to our final moments of boiling. As soon as this cools down, we're going to take it and filter it in here so we can get some of the cabbage extract.
We're using cabbage because of the anthocyanins inside, which is the chemical that changes color based on pH. So we're using the cabbages. You can use other fruits or vegetables as well, but cabbage is one of the better ones.
Super important to keep your lab station clean while you're working. It can get really messy really fast, so when you're doing things that may take some time, just take a few minutes to clean up your station. To have your goggles on at all times. Mine are blue. And there are times where you're going to need gloves, but in this experiment, we're not really working with anything super toxic or...
You guys think this is big enough? We can think about this bucket of water, this bowl of water as a reservoir. So reservoir is always like, kind of bigger than the subject. In this case, the subject is the red cabbage. So why we put the beaker inside the reservoir? Because we want the temperature of the beaker reach the equilibrium with the water in the reservoir. So once they reach the equilibrium, then we can change the water so that it's gonna get cold. In fact, I can do it right now. I'm gonna, get some cooler water. And then the temperature of this water, I don't know what is it, but I can feel it. The temperature this could be like 5 degrees Celsius. Still, I'm not using the SI unit of temperature, but if I use the SI unit of temperature, that would be Kelvin. So in Kelvin, that would be 255 degree Kelvin. So I am hoping I put that beaker inside the reservoir I have the same temperature, 255 degree of Kelvin.
You can already feel that the beaker is a lot cooler than before because now I can actually pick it up with my hand. And you want to stir throughout so that way you can get this to go a lot quicker. Room temperature. So Rashidul is going to filter this out.
Well, this is actually nothing but the cabbage. It comes from the red cabbage. So this is juice of the red cabbage. And now I'm going to filtering. In hope to separate the juice from the cabbage. Am I going too fast, sister? No, go ahead. Okay.
You guys can see the remaining
So this
pieces.
is the remaining of this guy, the red cabbage. So we don't really need them. In fact, I'm not going to put them in the water anymore. I'm going to put them aside.
It may take a little while for everything to drip out, but you might actually have more than enough.
Because this was a little warm before we started filtering, we just put 3 layers so that the paper doesn't rip. So we have 3 layers here, that's why you see multiple layers, and now we're just waiting for it to go through all 3 of those layers, which is probably why it's taking so long.
We still have the solution, the calcium chloride solution on the... Alright, so we just put the sodium alginate back onto the hot plate for a little while because it began to get clumpy again, so you just want to heat it a little bit so that way you have a thorough mixture instead of seeing all those clumps inside. As you can see, it's a lot more easy to handle now. So Off the sodium alginate from the hot plate, and now we're going to measure out 20 mils into this beaker because we're going to be mixing the cabbage extract in here as well. And this is really clumpy, so it's going to be really hard to move it from a graduated cylinder into a beaker. Okay.
And then we're going to add the 30 milliliters of cabbage extract to it. I'll give that a stir.
See that this mixture is very homogeneous. It's easy to tell that it's all mixed in. It's a lot thicker than before because of the sodium alginate, but it's very non-clumpy, which is what we wanted.
Okay, now we're going to take our solution with the sodium alginate and the cabbage extract, and we're going to drop it drop by drop. Each drop is going to then become a ball in our calcium chloride solution. And while we're doing that, you can have a partner stirring it.
Try not to stir where they're dropping, so that way you don't interfere. And you can see the ball starting to form. Oh, look how nice they look. So there are different ways of doing this. You can totally use a straw if you want to, but this dropper seems to be working very well.
One thing is the color of the ball is similar to the color of the cabbage.
So right now they look very purple, but I also see some blue. Who has a steady hand at this. It really just takes time to get a hang of it. They're very nice. They all seem to be the same size, which is good.
That's what we want.
That's the goal. Make them all symmetrical.
And they almost all are the same color, which is purple, the color of the cabbage. And how can you explain the blue? Because when Shristi dropping it and Lubna is stirring it, we see that the ball are forming and all balls are look symmetric, and the color of the ball we see they're like similar to the color of the cabbage, which is purple. Some of them are blue, but this is exciting because almost all of the balls are kind of like same size. There is no outlier. This is very exciting. Kids gonna love this. I think Lubna and Shristi gonna
I love it.
say something or agree with me. I don't know.
Yeah, this is definitely the best part. You notice that there's a lot of these chameleon balls forming, and there's a lot more indicator. So you don't have to use it all. You can just keep going until you feel like you have enough.
It's all the way over there on the rack at the top. Oh no, we do right there. Sorry. Bottom.
So it's about 0.34. So I want to have 1 gram.
We can do one
So
after
I'm
one.
doing it very carefully because I just don't want to have more than 1 gram. So that's about I don't know. That's about 97, 90 point. Oh, that's about 1. Wow.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells, while electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel coins you get. Copper, zinc, and gallium, germanium, and arsenic. Selenium and bromine, film, while krypton helps light up your room. Rubidium and strontium, then yttrium, zirconium,
Niobium,
molybdenum, technetium,
ruthenium,
rhodium,